live on YouTube right now. Okay, good. So we're all set. Okay, so first of all, thank you everyone for joining in, and thank you Jeremy and Henrique for accepting in such a short notice. We have quite a lot of participants. It's very nice to see. We're at about 80 people right now. So hello everyone, and I hope everyone is well. I wish you bon courage, whether you are in lockdown or people that are sick or just worried about the situation. So first of all, sorry for the confusion with the time. So some people joined in 1 hour ago because they reasonably assumed that GMT meant London time, but London now is at GMT +1. So we'll put some cities with the time next time, like New York and London, to avoid confusion. So we're starting a series of seminars where the idea is that the talks are about 30 minutes. We will not stop the speaker, of course, to give time for discussion. There will be 1 or 2 commentators giving a few questions for about 10 minutes just to get the discussion going, and then we will just open the discussion to everyone. So the topics are across disciplines. It's a wide audience, so it's from fundamental theory to experimentalists to philosophy of science. Generally, topics at the intersection of quantum foundations, gravity, and information. So we're testing the format. This is the first seminar, and we're open to suggestions on how to make things better. Do send us an email either to Lucas Hackl or Pierre Martin Duchot or myself. We'll be happy to consider your suggestions. We are starting with everyone muted because we're recording and it's also live on YouTube. But if you want to ask a question, you can unmute yourself and turn on your video. So talks will be available afterwards also on the YouTube channel of QISS. You can check upcoming talks on qiss.fr and also through the mailing list. And that is all I have to say. So welcome, thank you. And today's talk.
The pleasure and the compliment of beginning the series. I think it's quite apart from the awfulness of coronavirus, it's obviously a wonderful way to work, to travel less and try to think harder. So as Marios knows, and as all of you will have guessed, it's a curiously philosophical start to the series of what is, after all, a quantum foundations and space-time research consortium in physics. So you're about to get half an hour of pretty much straight up philosophy. Obviously you can quit Zoom at any time, I believe. So the poison isn't compulsory, but here it comes. This actually began with Henrique recognizing some issues in a recent literature about a buzz phrase invented by a philosopher, space-time functionalism, functionalism being a philosophy phrase, and related to the idea of one theory reducing another theory in the sense of the one theory being shown to be a part of another theory. And this talk will in effect introduce the general philosophy of reduction and functionalism, and then it will talk about space and time. And the initial spur was a paper by Gomes and Shyam, which the archive number is on the first slide there, 1608-08236, which is a sort of characterization of the ADM Hamiltonian. I will just touch on that at the very end, but as I say, this is a very philosophical presentation. So the rough idea of functionalism is that to be a duck is to quack like a duck and walk like a duck. So space-time functionalism is that space-times to be characterized, or any particular spatiotemporal concept is to be characterized by its web of relations to other concepts. And for you people in fundamental physics, one main theme of this recent literature in philosophy is the philosophy of quantum gravity literature, where one thinks of space-time as in some way emergent from non-spatiotemporal ingredients. But this philosophy literature also registers a whole other tradition where you say, no, concerning the theories that are established, let's look at the relationship between chrono-geometry or spatial geometry and the physics of matter and radiation. And in this way, one can envisage that you characterize a chrono-geometric concept by how it relates to matter and radiation. So the idea would be the metric is as the metric does. The metric is to be analyzed in terms of how it encodes relations about goings on of matter and radiation. And that's a question that you can ask about an established theory without in any way saying that space-time is emergent from something utterly non-spatiotemporal. So
you take questions, or do you prefer questions at the end? What is the rule? Just
I'll be guided by Marios on
so
this.
question at the end, Marius. It's just a very short question. It's not.
Marius, you're muted. You're muted. We didn't hear your answer.
So if Jeremy would like to accept interventions, sure.
Great. Okay, so
just to avoid just a terminological thing. When you say the metric is blah blah blah, and you mention matter and radiation, here every time you say matter radiation, you mean excluded the gravitational field or not?
yes.
Okay.
Yeah. Okay, so there are three themes that Henrique and I are preoccupied by. As on the slide, the recent literature has missed some traditional insights about reduction and functionalism, what in English they call home truths, meaning things one should know from learning at home. And then there are some precursors of these insights that, without using the word reduction or functionalism, that you find, and I'll pick Arthur Robb, Cambridge mathematician interested in axiomatizing special relativity, and David Malamant. And then in technical physics, a sequence of papers, I'll only talk about Barbour and Bertotti and mention HKT and Gomes Shyam. So as I say, that they're going to get short shrift, I'm afraid. So it's mostly themes 1 and 2. So I want to emphasize that functionalism is a form of reduction, where if you take a concept or property in the theory that is being shown to be part of another, you characterize it or you uniquely define it by, here's the jargon, the functional role, which is like the pattern of relations it has to other similar concepts and to concepts that belong to the reducing theory. And in Robb Malamant example, the idea is you have a notion of simultaneity, you spell it out in terms of causal connectability, and it is to be an equivalence relation that in which no two time-like related point events are related by the simultaneity relation, and so on. And then you prove that Minkowski orthogonality relative to an inertial time-like line defines those equivalence classes as the hyperplanes that are orthogonal in Minkowski geometry to the given inertial line. And in HKT of 1976, there's a deformation algebra of hypersurfaces, which is a sort of kinematic notion that is then required to suitably relate to the dynamics of spatial geometry over time, and the ADM Hamiltonian is characterized. So the philosophy leitmotifs in this will be, these are buzzwords that we've introduced. There's going to be a problem of plenitude, where you have too many definitions, where you want just one. And there's problems of scarcity, where you have only one definition. I'm sorry, not even one definition. And there is a Bertrand Russell one-liner about theft versus honest toil, which comes in. And in the more dull jargon of modern philosophy, there's the idea that a reduction might only succeed in some relatively small domain. And when you go beyond that domain, you have to face the idea of the concepts of the theory that is being reduced being instantiated in very many different ways, multiply realized in terms of the jargon or the concepts of the theory that's doing the reducing. So this is then the shape of what I'd like to say. There's the reduction in general, and then there's the functionalism in general. Then I'll say a tiny bit about Robb, then I'll say a tiny bit about Barbour, Bertotti, and HKT, with that final section being actually about not so much chrono-geometry as a whole being reduced to other concepts, but the temporal metric in particular being reduced to other concepts, which means in effect being defined. So here's the broad philosophy beginning then. This is about home truths about reduction in general. There's a contrast in many philosophical projects between what you might call the troublesome discourse or collection of concepts and what you might call the okay discourse or collection of concepts. So there's a discourse with a collection of claims. It uses concepts that are special to it. It may use other concepts as well, but it has some small list of special concepts. And your feeling as a philosopher is that there's the okay discourse and concepts, and then there's the troublesome one. And the standard examples are legion, but you might say material talk is unproblematic, but mental talk is problematic or troublesome. That empirical talk is unproblematic, but it's mysterious what pure mathematics is about and what its concepts really refer to. Or that the observation, in the philosophy of science, the observational is unproblematic, but the theoretical is problematic. And one response to that general contrast is to say, I am going to legitimize the T by revealing it to be, in fact, part of the O. And of course, T, troublesome, and O, okay, are cleverly chosen as mnemonics, so that you have T for theory, O for observation in the standard philosophy of science. And but the pattern is more general. The troublesome will be shown to be part of the okay. And this showing it to be part is called reduction. And of course, there are little qualifications to the general enterprise. Okay, not perhaps all the troublesome claims, just some favored subset of them. And the OK realm might need a bit of extra turbocharging. You need to augment it with other ingredients. So there are classic examples here in the philosophy of mind, in the philosophy of maths, and in particular, the so-called logicism of Frege and Russell was very influential. And in the philosophy of science, and this is closer to our concerns, Rudolf Carnap in the 20s was very like Bishop Berkeley in the 18th century in suggesting that talk about the material world of tables and chairs was actually troublesome and was to be reduced to talk about sensory experience, which is the ultimate ambitious program of idealism. But in this enterprise, you've got to actually be honest about it and deduce the claims of the troublesome discourse. You shouldn't just postulate that you have the right from within the okay discourse to talk the language of the troublesome and declare that you have secured, recovered legitimize the troublesome, you must deduce it. And hence this classic one-liner from Bertrand Russell, who had a very good way with words, as many of us know. The method of postulating what we want has many advantages. They are the same as the advantages of theft over honest toil. And then he, of course, typical Cambridge, grab the moral high ground if you can. You know, that's what we do in Cambridge. Let us leave them to others and proceed with our honest toil. He's patting himself on the back for the big efforts he made with Whitehead in a book, Principia Mathematica, that we can no doubt discuss in discussion time if we want to talk about pure philosophy. So when you do this kind of thing, you face obstacles or problems or accusations. One would be somebody says to you, now this is where we get to all have the fun of speaking some Latin. The English word definition is ambiguous between the complete statement that some symbol alpha is to be defined by A, B, 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 C, C, C. And the definition could be that whole stipulation, and it can also be the A, B, 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 C, 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 the detailed stuff that conveys the content. So we use Latin from medieval times, I think, to distinguish. What is being defined is called the definiens. Sorry, what is being defined, the alpha, is the definiendum, whereas the long bit is the definiens, right? The AA, BBB, CCC that tells you what alpha is. So an accusation of faithlessness is the accusation that the definiens is not true to the original concept. On the other hand, you could say, this enterprise is bound to fail because it leads to too many definitions that are all equally good. You cannot choose between them in a non-arbitrary way. Therefore, you have failed to uniquely define the definiendum. And scarcity is along the lines of not even one definition is good. And there are various strategies for replying to these. You can require the definitions to be suitably short and conceptually unified if you face a problem of plenitude. You can say, I don't have to be true to the original concept. I'm allowed to be a little revisionary. And here, in all over philosophy, you find a contrast between a Cambridge 20th century tradition associated especially with G.E. Moore of you must be faithful to the concept. We call it conceptual analysis. And a Rudolf Carnap and others tradition that allows you to be revisionary, and it's called explication. So you are allowed to somewhat revise. But the result of all this is then that one has a TOK and a T troublesome, and that TOK will have judiciously chosen definitions added to it in such a way as to imply T troublesome. So T troublesome is no longer troublesome. It's a sub-theory of TOK with these judiciously chosen definitions. And this is the classic philosophy of science tradition, especially associated with Ernst Nagel, about understanding one scientific theory to be revealed to be part of another. And the idea of definitional extension has been criticized as being both too weak and too strong. There are cases where it seems to be a definitional extension is there, but it doesn't look like reduction, and other cases where you think you have reduction, but it doesn't look like a definitional extension. Ernst Nagel actually replied to that pretty well, but there certainly are, even when you look at his clever replies, issues to be faced, right? And there's some mention of those at the bottom, which we can come back to. One main theme is that the instances of what you are defining, the definiendum, may differ greatly from one another, even in respects that are candidates to enter the definiens. And if so, that will mean that your definiens has to be very long, maybe very disjunctive, saying AAA or BBB or CCC. That is my definition of alpha, right? So it's a long sequence of specific ways that alpha can be instantiated with or put between them. Or you say, no, I must avoid such a long disjunction, but have just to confine my endeavor to a specific local domain in which I achieve the reduction. Neither of those needs to be bad news, in my opinion, but another kind of obstacle is worth emphasizing. It's a threat of circular definition. And this is worth emphasizing because it leads into functionalism. You see it in the effort to understand the mental in terms of the material, which means traditionally talk about belief and desire would be understood in terms of dispositions to act by the organism given a certain sensory stimulus. And this endeavor of defining, as it might be, belief that it's raining in terms of a disposition to pick up an umbrella if the organism is, say, a human being is going outside, that effort seems to stumble on needing to refer to the human being desiring to stay dry. Mental concepts are not fully analyzable in terms of behavioral concepts, it seems, because you need to invoke other mental concepts in order to spell out the detail of the disposition to act under certain sensory stimulus. But similarly, when the effort to define one mental concept seems to invoke another mental concept, the effort to define the other mental concept will likely invoke the first one. So there will be circles of logical definability preventing you ever succeeding, right? So there's the logical circle there is in the vice versa on the slide. You will need, in order to define desire to stay dry, to refer not just to picking up an umbrella when going out, but also belief that it's raining, right? Okay, so functionalism is a buzzword associated especially with Putnam and Armstrong and especially Lewis in the 60s and early 70s, and it overcomes some of these problems of reduction. Here we fill out three main features. One is the idea that you specify a property or concept uniquely by its web of relations to other items, including concepts and properties. And that web or pattern is called a functional role. Now, the fact is that almost any property is under widespread circumstances uniquely specifiable. And being locked is a standard example. It is, if you take a combination lock or a padlock that is not a combination lock, the notion of locked is clearly not definable in terms of some specific material configuration. In a combination lock, it's to do with 2, 3, or 4 pins being aligned or unaligned. In a padlock, it's to do with some single hunk of metal entering a hole in a certain way. But if you allow yourself things like inaccessibility or security as concepts, you can spell out lockedness in terms of its functional role, which is realized multiply in different ways in a combination lock versus a padlock. So you begin to see the kind of complete genericness of the notion of a functional role. And almost every concept can be specified by some such pattern. But it is often hard in science when you are endeavoring in technical inquiry to reduce one theory to another. It is intellectual work to specify a fruitful functional role. And in fact, Malaman 77, HKT 76, they're exactly involved in such an endeavor. Right? So this contrast between the role and the occupant is just like theater. as in Shakespeare or other plays. And it leads to another main theme, that identifying lockedness with, as it might be, the pins being not aligned, and unlockedness being the pins being aligned, that identification is compulsory, it's not optional. If you have an inference with the following shape, that P equals S and C equals S, there's undeniably the valid inference that P equals C. And here is a standard example from Lewis showing this compulsoriness of the identification that functionalism gives you, where my little notation P, C, and S has been deliberately chosen as a mnemonic to link to the example. You see, you can imagine that you're an aspiring logical behaviorist who wants to do a conceptual analysis of pain. And you say, well, it's something like a mental state that's typically caused by tissue damage and typically causes distress and a behavior to avoid the cause of the tissue damage. Well, that's something like a conceptual analysis or explication of pain as a piece of folk psychology or a platitude of common sense without needing technical empirical inquiry. But on the other hand, contingent technical empirical inquiry of neurophysiology may find that a certain state of the brain called C fiber firing is indeed a state that is typically caused by tissue damage and typically causes distress and aversive behavior, in which case you must identify pain with C fiber firing. That is a mandatory inference if you believe little Roman 1, little Roman 2. And it has analogues in established technical physics, of course, all over the place. One classic example would be Maxwell concluding that light is electromagnetic waves, because he identifies through his ratio of the two constants something like the functional role traveling at 3 times 10 to the 5 kilometers per second, and thinking, so light is electromagnetic waves. Of course, it's rough. Here, uniqueness might fail. Maybe something else travels that fast. And of course, with the advent of general relativity, and indeed confirmed with LIGO, we know that something else travels that fast, right? So the other thing is to avoid the logical circles. Several, even many concepts can be simultaneously defined without logical circles. The traditional threat of circularity can be answered. The reason is that a body of information can be sufficiently rich that it simultaneously specifies several items, in part by their relations one to another. This has a natural illustration from a game that in England we call Cluedo, which I hope is a global game where the players gather information by asking each other questions. Every player gets cards. Every player must answer the other player's questions about which cards they have. Every player must answer honestly. It's a game of chance without skill, the kind of game I like. No skill is required. You just have to get lucky that you happen to have asked the questions of your competitors that reveal to you the information that the murderer was a certain person, that it was done in a certain location and with a certain instrument. And you win the game by announcing this information that you have gathered by looking at your own cards and the cards of the others. There's nothing paradoxical about a set of information, a collection of information being rich enough to specify 3 things at once. And indeed, going back to the theatre example, some of you may know that in the 1970s, our excellent actor and actress McKellen and Dench were Macbeth and Lady Macbeth in a Shakespeare production, and it was the best ever, or at least it was the best in 20th century Britain. And it's perfectly reasonable for me to simultaneously specify those 2 people uniquely, all at once, in a single definition. Okay, so in effect, you systematically extract from a whole theory specifications of many things at once, right? Okay, so now at last we get to some space and time. And I've only got about 7 minutes, I think. Am I right, Marios? About 7 minutes?
Yes, we have still about 7 minutes.
Yeah. So functionalism about time is going to be the main thing from now on. And I want to look at Robb and Malamant and then Barbour Bertotti. And we're going to be really in the Robb Malamant example, thinking about the temporal concept of simultaneity. But in the Barbour Bertotti example, we're going to be thinking about the definition of the temporal metric. And I have to, again, perhaps interpolate a misgiving to you advanced physicists that this is going to be a curious case of stuff you already know, wrapped up in words that will be new and possibly confusing, and even if not confusing, not welcome, right? They're not going to particularly help you to understand the physics of your example. But they are, in effect, what the taxonomy of philosophy discussion about the relationship between theories, reduction, functionalism, what that philosopher colleague brings as a word bag of words to discuss your technical examples. So anyway, what's happening here, again with mnemonics, is that Robb and Malamant have got a representation theorem. It's got the shape that all items that satisfy some abstract description are identical to, or they're isomorphic to, or they're embeddable in a concrete object, call it C. But this identification or isomorphism has a well-controlled freedom, call it F, which it means that this embedding or isomorphism is kind of unique up to a certain transformation, call it T. So typically F is a Lie group, like the Euclidean group, and T is a member of F. This is quite different from what the aims of representation theory are, of course, where, of course, that game is take the abstract description A, for example, an abstract group, and now find all concrete objects C that are each of them homomorphic to the abstract A, for example, set of matrices, right? So A for abstract or acceptable or a priori, which is a bit like okay in the previous jargon, C for concrete or constructed, which is a bit like troublesome, okay? So what are the basic themes going on here? Well, perhaps for physicists, the most important thing is the one at the bottom of slide 17, that the specific isomorphism or embedding is a bit like a gauge fixing. It's often useful, indeed indispensable, and it's harmless to make the embedding into something concrete. And the F encodes the range of choice in the embedding. It's like a choice of coordinates. Arbitrary coordinates are acceptable, but often there's a sensible choice about what's most empirically or calculationally useful. And in the broad philosophy here, up top half of the slide, we've got the themes that the A is okay and it's general, the C is troublesome perhaps and it's special. And what's happening with the representation theorem is that in effect, the C is being legitimized. It's being shown that A is not really a generalization of the troublesome C, because every time you say A, you are in effect up to an isomorphism or up to an embedding committed to a C, right? So in the relationist tradition, which perhaps in the discussion period we can come to, this particular idea that the C is troublesome and special, but is legitimized by being shown to be something you're committed to, even when you say A, because every A has a representation up to a freedom given by a set F of transformations T. That'll be a theme, okay. So here in Cambridge, in one of the streets, an obscure mathematician, Arthur Robb, wrote a book, 1914, in which he said Hilbert has axiomatized geometry in 1899 in an influential application of the modern mathematics methods of the late 19th century to the canonical Euclid. And he said, I will do the same for Minkowski geometry, recently articulated by Minkowski 1908 onwards. And this endeavor then involves an axiom system by Robb, which governs a domain of points about which he postulates a single binary relation. He calls it after. It represents causal connectability between, in effect, points of R4 equipped with the Minkowski metric, right? So A is a collection of axioms written in mathematical English saying things like, between any two points there lies infinitely many others, which is true. He's talking about line segments in Minkowski geometry, right? So it's a bit like Euclid. It's what's called the synthetic approach to geometry, but it's done for Minkowski geometry. And the C is Minkowski spacetime, and F, of course, is the Poincare group, because Hilbert in 1899 had the Euclidean group, right? So this is the general idea of Robb, and it has a legacy in the 60s with people like Christopher Zeeman writing about the relationship between causal structure and metric structure in Minkowski spacetime, because that relationship of causal connectability is, of course, much less than metric structure on the face of it. But the whole point of Robb is that he's able to get a representation theorem that he can build Minkowski geometry, the metric structure, the affine structure, things like orthogonality, by very long, carefully chosen definitions based in the notion of after, about which that's his only primitive relation. So it's a sort of heroic achievement of traditional synthetic geometry applied to the deliverances of Einstein and Minkowski. We can, okay, I realize I'm up to 30 minutes now, dear Marios. Shall I just talk for 5 more?
Sure, yes,
yeah,
please.
So just to try and bring this to some sort of conclusion, that we can exhibit the features of philosophers' notion of functionalism here. Let's do this, as I announced, for simultaneity. But since the full Minkowski geometry is in fact defined in terms of after, you could illustrate it in terms of other aspects of the temporal metric or the spatial metric. So Ballamant in 1977 has a proposition 2, which says, take an inertial, he doesn't use the words reduction functionalism, he does cite Robb. I'm just going to package his achievement and Robb's achievement in the more ambient jargon of philosophy of science. His theorem is along the lines of, think of an inertial world line L, an infinite time-like straight line in Minkowski space-time, the usual relation of simultaneity relative to L that you learn in your relativity textbook when you learn that relativity is frame dependent. It is the unique non-trivial equivalence relation on R4 that is definable from causal connectability after, meaning Robb's notion, and the relationship of a point being a member of L. Okay, so simultaneity in a Newtonian spacetime with its absolute simultaneity slices might well be defined as causal non-connectability, right? So coming from a kind of space-time formulation of Newtonian notions of cause, you might say, oh, well, Newton's action at a distance was, of course, instantaneous. But setting that aside and thinking that Newtonian spacetime admits arbitrarily fast causal signals, but does not admit infinitely fast causal signals, you might say the absolute simultaneity slices of Newtonian spacetime are precisely the equivalence classes of causal non-connectability, right? And you then might then throw up your hands and say, well, in Minkowski space-time, causal non-connectability is, of course, space-like relatedness, and it is what is often called in the textbooks the elsewhere, and it's got a much more intricate structure than the foliation given by causal non-connectability in the Newtonian setting. But you would throw up your hands and say, it'll be an impossible task to try and define orthogonality in Minkowski geometry in terms of causal non-connectability or causal connectability. And that would be a reasonable intuition. But Robb has undertaken this apparently tough task and succeeded. That's the content of the Malaman theorem. In fact, it is the unique non-trivial equivalence relation. Non-trivial means just, it's not the universal relation where every point in Minkowski spacetime is considered equivalent to every other. And it's not the empty relation where every point is itself in its own equivalence class, right? So anyway, that's what Robb and Malaman succeeded. So to finish off, how would we think of this in this enterprise? Robb presents a theory with troublesome terms like simultaneity, elapsed time, and one okay term, causal connectability. And from this theory, we can extract functional roles of the troublesome terms. And for simultaneity, it's something like being the unique non-trivial equivalence relation that is definable from after. And Robb gives a long definition in terms of after of that relation. And Malaman proves that it uniquely satisfies the extracted role. So it's a lot like what I had before with pain and C fiber firing. Simultaneity is like pain. Robb's long definition of Minkowski orthogonality is like the physiological finding out what C fiber firing is. And the conclusion that pain is C fiber firing is like saying pain is Minkowski orthogonality. Okay, so there are ways we could fill out the philosophical morals of that. Let's do that in discussion. In Barbour and Bertotti's 1982 theory, just to finish off, I can do the same. And let me come back to that if people want to in discussion. I apologize for overrunning. I would, in a final slide, summarize that HKT can be regarded as playing the same kind of game. They postulate that there is a Lorentzian manifold. They then characterize the Hamiltonian governing time evolution in a certain sense, in a certain natural sense as being unique. So they have a Lorentzian manifold. They then adopt a 3+1 perspective. They consider three-dimensional hypersurfaces. They talk about the embedding of space-like slices into space-time. They introduce a deformation algebra into this discussion with quite a lot of clever technical apparatus. And they then show that with this apparatus, if we had transcribed some natural requirements about the meshing of the embeddings into a Hamiltonian framework, then the Hamiltonian has to be the ADM one. So in philosophers' jargon, they show that the ADM Hamiltonian is the unique occupant of a certain functional role, right? What I want to advertise about Gomes and Shyam is that they have a similar unique characterization of the ADM Hamiltonian, but without assuming that there is a Lorentzian manifold. There's no space-time really. There's a 4 manifold, but they don't assume a Lorentzian metric. So the final slide. Various endeavors in the philosophy and foundations of space-time theories illustrate themes about reduction functionalism. There are various examples yet to be explored. I'd like to talk about Nick Huggett's 2006 and Belloc's 2012. And I should talk about NOx. These are things yet to be undertaken, but in particular, I do commend to the physics community my dear colleague Henrique's 2017 paper in Journal of Mathematical Physics. So thank you, and let's have a discussion. Sorry for overrunning.
Okay, let's take the speaker.
Thank you.
Okay.
I'm sorry for overrunning.
No worries. There's actually many participants we just unmuted. So thank you very much, Jeremy. And so now we will start with some questions. The commentators today are, because we put this together in a rush, it's going to be Pierre and myself will give you a couple of questions. Then I don't know if Henrique would like to ask a question or say something at this point.
Well, I think I can. I would, unlike Jeremy, I would not recommend my paper with Positive because it's a, as he says, a letter soup. But Jeremy and I will have a more readable account of that paper soon enough. But we can talk about the content of that. And I think I should leave any questions for after the commentary by you too, because so that there is no overlap of my comments with yours and Pierre's.
Okay, great. So Pierre, you wanna?
Yep. Yeah, I can. Can you hear me?
Sure, I can hear you. Yeah.
Okay. So hi, Jeremy, and first, thank you very much for your talk. So I'm trying to understand functionalism. And so before your talk, I've been on Wikipedia and I've read the Wikipedia page about functionalism, but it was not about physics. It was about architecture.
Yes.
So it was very interesting
Yes.
page about what is functionalism in architecture.
Yes.
And so basically says that a building, depending on its function, will be built in different ways.
Yes.
And I think that's pretty much in the same direction of what is functionalism in philosophy as you've described it. And it's even more related to the questions that we are interested in, because in 3 weeks, there will be a virtual seminar by Eugenio Bianchi about the architecture of space-time.
Yes.
And he is going, I mean, I don't know what he's going to talk about, because I can imagine that he's going to talk about some kind of emergence. And here with the QISS consortium, one of the big questions we would like to understand is how does classical space-time, which is the troublesome, I would say, emergence from some quantum thing, which is the okay part.
Yes.
And so this is the way I'm thinking of emergence in physics. And my question is whether you could comment on this relation between functionalism and the kind of emergence I've just mentioned.
Yes.
Is this something completely different or what?
This is a very helpful question. Thank you. It's not. The truth is that when Gropius and the others in the 1920s called it functionalism, they had in mind the goal or the purpose of the building. And as you said, the idea was you make the design appropriate to the purpose or goal of the building. How will people use it? Actually, just boring report from the philosophy world, we use the word without the connotation of goal or purpose. It is true that the locked example that I took suggests purpose. The idea is you need something that can make a valued object inaccessible to people. So the web of relations, which I was emphasizing, is in normal life very often related to human hope or purpose or goal. But the general idea with the kind of, you could feel the atmosphere of logic in that first 2/3 of the talk, right? It's all about extracting a simultaneous definition from a long body of doctrine and so on. There's nothing there about, oh, the definiens must be related to purpose. But more important, I think, is a second aspect of your question, that I'm glad to report that although I said nothing about it, the space-time functionalism literature does relate to the emergence of a space-time classical continuum from something quantum, not yet settled by us in physics. So the philosophy of quantum gravity community, and of course, Pierre, you and I happened to be online before we began by some 10 minutes, and we saw that Nick Huggett was with us then. So, you know, this sub-community in philosophy of physics does engage in that way. And Pierre, you're absolutely right to say that the vision must be, in my mnemonic jargon, that the emergent is what gets reduced to something more fundamental. And therefore, although actually general relativity is established and beloved, and we know it, whereas the underneath is unknown and going to be tough, the words troublesome for the emergent classical GR and okay for the yet not yet known, those are unfortunate labels. Because in fact, where we stand now with our, you know, having not yet solved quantum gravity, you'd like to put the labels the other way. But the logic of, you know, the narrative logic of my presentation with my examples was, of course, something like, okay was a good label for my, because I wanted to say to the space-time literature, space-time functionalism, recent literature, hey folks, look, neat ideas that you have, but by the way, 100 or 50 years ago, there were examples of this, and you never mentioned them. You acted like these were not relevant. So there's a kind of passion of an old man to remember the old examples here.
Thank you.
Yeah.
Pierre, do you have another question?
I do. Yeah. The other question is, again, in the same spirit of understanding functionalism, I was looking for examples, and I was wondering whether the least action principle in physics, which is used a lot, can be seen as a way to define, for instance, the gravitational field. Because, for instance, we have this. You are mentioning a theorem about ADM
Yes.
Hamiltonian. How we can motivate the ADM Hamiltonian. This is the last slide of your talk, but I was also thinking of Lovelock's theorem. So to remind everyone, Lovelock's theorem is a theorem which says that basically the only possible equations of motion that can be obtained from a local action principle, which is sufficiently simple, are Einstein's equation on a manifold. And so this seems to be also a kind of theorem similar to the geometry dynamics regain that we are seeing here, which seems to motivate some form, some shape for equations based on some other principles. And so I was wondering whether this Lovelock's theorem could be seen also as an instantiation of functionalism.
I'm very grateful to you again. I totally agree. This is a very quick and accurate insight by you. I think it is. When in theoretical physics, the theorem has the shape the unique X that does job J is ... one is in this general area of logic and philosophy. And the distinction of functionalism in Lewis is picking up on that unique definability idea, but also the simultaneousness of it for several different things. But a representation theorem like the Lovelock, I totally endorse that. Yeah. But there is this old joke, which I won't repeat, about having the intellectual policeman. There's one day when we meet face to face, I'll bore you with the full detail of the joke, but the real wizard is acting the chauffeur, and the chauffeur is acting the person who knows it. And so in the joke, at the end, the difficult question is asked, and the real chauffeur acting the academic says, "That's such a simple question, I'll ask my chauffeur to answer it." So my chauffeur today is Henrique Gomes, who may well have a comment on
yeah, I would say, yeah, it is very similar, but I think one of the defining features of functionalism is this this separation of domains, of problematic domain and an unproblematic domain. And I think you can think about how to appropriately separate those two domains or those two vocabularies. Also in the case of Lovelock's theorem, if you want to say something like, well, the equations of motion or the dynamics, and what are my constraints on the kinematics or on the types of Hamiltonians or something like that. There is a little bit of work to be done to justify these two domains and say why one would be problematic and the other less problematic. But I think, yes, it can be put on this language. You just need to justify a little bit why. You see, because these are given almost for free for us in the more traditional examples in philosophy, like the theoretical versus observational and so on. In this case, there's a little bit of work to be done.
Thank you.
Okay, great. So let me ask a quick question, and then we open the questions to everyone, because we have already done some time of commentary. So my question overlaps with what Pierre has already asked. I just want to give you the chance, both to Jeremy and Henrique, to explain a bit how you see this methodology or strategy for theory building, if I understand well, to help determine or explain chrono-geometry, which is something that was mentioned as central in the first slide, through matter. So I guess I just just to get the hang of it, is the idea to explain, so what is troublesome? Is the idea to explain experience through theory? Is the experience that is troublesome and the theory that is okay? Or is it, this is something I'm not very clear on. And in particular, I have the impression that, so somehow we're taking the behavior of classical matter, like particles and light, as something that is not troublesome because we understand it well and also empirically, and elements of space-time theory or of general relativity, like diffeomorphism invariance, they need to use foliations, which are a bit esoteric aspects, to be the troublesome ones that are going to be explained by the motion of matter. So I'd just like a comment on this, and first of all, if it's really like that.
Yes. Well, I'll go first, but Henrique should comment more. This is my comment will be you kind of trivially true and a bit frustrating because not adding very much. When we were drafting this paper, we realized, and this is true in the Barbour Bertotti and the Robb Malamut and some other examples we had in mind, that there was this tradition, I didn't really mention it, I think, relationism, which is the kind of suspicion of chrono-geometry being postulated outright as a property of space and time. And you find it in Leibniz, right, through to Mach and beyond, that material bodies and our knowledge of them are a more secure basis. And as you said, Marios, you know, classical particles and light are okay, whereas maybe space or more specific concepts like metrical concepts for space or time are troublesome. And certainly, yeah, that is undoubtedly a theme of the examples I wanted to rehearse. And you kind of rub the noses of recent space-time functionalist philosophers in these old relationist examples. It is not, however, always relationism, and the Robb Malamut brings that out, because Robb has no hesitation, just as Euclid postulates the Euclidean plane, and Hilbert postulates the Euclidean plane. Robb is happy to have, as we would say in logic and philosophy, a domain of objects that he's committed to the existence of, which are enjoying this relationship of binary relation of after amongst them in pairs. And then he proves that that thing is isomorphic to R4, with after being, so to speak, a non-symmetric version of time-like or causal connectability, but it's the non-symmetric one, hence the word after. So this doesn't especially help in the physics community's efforts at new theory construction, but that certainly is the logic of those examples. But Henrique, you should comment if you wish.
Yeah, so I think, well, one of the comments that I had reserved just from looking at the talk is just a very brief one about how the name functionalism was resurrected, and whether it was correctly resurrected is another question. But the point that I think Eleanor Knox and other people were making was that the notion of space-time that emerges, well, that one uses in Newtonian theory, is a very different notion of space-time than one would have in mind for relativity theory. So what does the word actually stand for? What does space-time actually stand for? And then there was a proposal of a functional role that you know, space-time is anything that has some inertial structure. And we wanted to connect this back to the more formal analytic philosophy of the 20th century. And in a more, well, we've also found other examples like the one that Jeremy mentioned of Duhl, Schuller, and Giesel, which does try to see the implications of a certain type of functionalism for theory building, in that they look at what kind of equations of motion of matter would fulfill a certain functional role of predictability, for example, of what kind of equations of motion and what types of matter would allow you to have make certain predictions about the future and other things like that. And and then there's a theorem that using these types of matter fields, you can try to define a space-time. So in these types of theories, you would try to build theories for which space-time has this associated role with predictability. And well, it's a complicated, very algebraically heavy formalism that they employ, and it's also very flexible in the sense that you don't need to apply it only to the types of matter fields that we know. And yeah, there is a certain role for it in model building, but I don't know to the extent in which it has been positively used. For example, in the proposal of new types of theories, what I understand, at least from it has maybe a better role in discarding theories that would not give you a certain functional role for space-time. So, for example, in this work with Gomes Shyam, we show that if you require a certain property from a Hamiltonian of GR, even if you don't even think about a space-time, even a four-dimensional manifold, so you don't really apply for diffeomorphism invariance to the theory, and you restrict in certain ways the Hamiltonian, you find that the only Hamiltonian available is in fact the ADM Hamiltonian, or canonically something canonically equivalent to it. So in that way, you kind of discard other theories by just saying they would not fulfill these requirements that we have of I don't want to bore you with the details, but it's basically about meshing and about different observers being able to describe time differently and yet refer to the same universe, something we call meshing. And so I think there is a role. I don't know how much this role can be translated into something positive. I think it is easier to translate it in something negative, so far at least. I don't know an example of a new theory that has been found by just focusing on realizability of some functional role.
Okay, great. Thank you very much. So we're going to allow people to ask questions. So you can raise your hand on the so that I can give you the question. If you don't know how to use that function, feel free to just unmute yourself and ask. So there is Carlo and Francesca that have a question.
Jeremy, and thank you very much for this. I have a reaction, and I want to know how to you answer to that. I found that, Jeremy, your discussion of what is functionalism, how to think it in terms of reductionism and what it means, extraordinarily clear. And for me, it was great. It put a lot of things in order. I am very confused as a physicist of the relation between that and space-time. And in fact, I'm pretty confused as a physicist of the relational between everything you've said and physics. And I want to articulate that, but let me put it in a slogan. The slogan is that what I found troublesome is not the troublesome, is the unproblematic.
Yeah.
Namely, once I phrase a problem in the way you have at the beginning, namely, let's consider something unproblematic, because we agree that this is a good starting point. And let's, on this ground, see if something that we agree to consider troublesome, can be, the troublesome part can be addressed by functionalism, by perhaps other form of reductionism. Wonderful. I'm completely on your ground. But once I go to physics, and in particular, you started off by saying this should be useful for gravity and space-time physics, by understanding space-time. It seems to me that the entire issue is not what is troublesome, is what it is. What are we going to consider unproblematic?
Yeah, yeah.
Right? Now let me be a little bit more precise, and I want to say something very fast about the three examples that you mentioned. Malaman 77. It's a paper. It's a work I encountered because John Norton, at some point during discussion with John, he pointed out to me, and I studied, and I was furious. And because I said, this is total nonsense. It's wrong. And now I listening to you, I realized that I got it wrong. I mean, now I understand what you mean, and I understand how good is that result. And the reason of this misunderstanding is because I am misunderstood from John Norton, and I don't know whether it was him or me or the communication, that what Malenton had done was to completely undermine Robb by showing that what is in GR, what is in special relativity, what is simultaneity, is just orthogonality and had nothing to do with causality. That's what I understood from Norton. Like if Malenton was saying, "Oh, this has nothing to do with causality," and my reaction was, "No, wait a minute. I mean, this is orthogonality is just the way Minkowski geometry captures causality. It's nothing else." So it's now the way you presented it, it suddenly everything makes perfectly sense. Namely, what Malenton did is not at all to undermine Robb, it's the other way around, to show that indeed it does capture the unique notion that we need in another way. But this means that the way, what I understood from John Norton and what I understand from you, and it seems more clear, is what is the O. Okay, what is the unproblematic part that we're giving for good? So if we take as unproblematic the Robb actions, we understand everything. And that seems to me a beautiful piece of thing, which give precision and credibility to what Einstein did in 1905. Now, the same is true for Bertotti-Barbour. Bertotti-Barbour published 2 papers in the 80s. I know very well because I was working with Bertotti at the time. I was going to see him from Verona, taking my little car, driving to him. We were working together. We had a paper together, which we never had published. And what they did is, first of all, derive sort of chrono-geometry from matter in a non-relativistic case. Beautiful paper. And then shortly after, tried to do it with GR and ended up to the totally opposite result of what they hoped for before. Namely, their result was that you do not get chrono-geometry from matter, you only get it from the metric itself, from the gravitational field. So let me conclude and come to the key point. You said, can we use all that in a spirit of getting understanding space-time out of matter alone? And I asked carefully at the beginning, do you mean matter without the gravitational field? If this is the problem, if the O of your OT distinction, you're building everything, is just matter without the gravitational field, it seems to me that it is 100 years, and I'm a talking physicist, not a philosopher, that we have understood that this is not possible. And I haven't seen any even minimal hint that this is possible. The physics of space-time is not, I mean, there was a moment in which Einstein himself was confused about that when he thought that his equations, the Einstein equations, have no solutions within a matter, and the solution is uniquely determined by matter. But we know, and Einstein realized very soon, thanks to de Sitter and many other mathematicians, that's definitely not the case. And in fact, Einstein himself clearly get to the understanding that what we learn from general relativity is that the O on which we can build everything else cannot be just matter without the gravitational field. The gravitational field is a part of the ingredients irreducible in our description of the world. Whether you want to call it space-time or not call it space-time, it's just a matter of words. But it seems to me, and that's a foggy part in which I heard, that starting off by saying, oh, this might be useful to understand how space-time geometry emerged from matter, meaning matter without the gravitational field, just radiation and matter, that's hopeless. That's my reaction.
Yes. Well, thank you so much, Carlo, both for, so patiently sitting through this, but also the insight of your comments, because in a way that may be a bit boring, but at least is peaceful. It's the nature of the friendship. It's dull, but it's solid. That's me. I completely endorse what you've said, man. When you first said, to put it in a slogan, I want to urge that what has been treated as okay is often problematic. In a completely general way, before we got to the Malamut example or the GR example, I just endorsed what you were saying, because it's just that at a certain, you know how it is, the philosophers come in after the empirical inquiry is mostly over and they tidy, or maybe they're in pure philosophy and they just think some things are to be built on and other things are to be examined in a skeptical way. So they're sort of problematic. But the fact is that the ontologies that you physicists over the centuries build, for all their precision and impressiveness, they seem, as my pure mathematician friend once said, a curious way to make a world, right? The ontologies of whether it's Euler's and Boskovich's point particles through to the vortices of Kelvin and others, through to, whatever now in the 20th century and beyond, they're very fragile, these ontologies, and they always repay scrutiny, right? And of course, we have all met in our social life in discussing the shape of scientific knowledge as we have it in our culture. We meet what you might call naive medical and engineering people who think that there's no question that all of the cosmos is built on tiny billiard balls, as revealed by high school chemistry, right? And they have an unproblematic attitude about reductionism of everything to a kind of classical biochemistry. I mean, my father was a doctor, and bless him, I mean, he's been dead 20 years, but he did say, love is really molecules in the brain. And I nearly said, no, Dad, that's just the occupant of the functional role. In one local reduction, right? But to turn to your more specific physics examples, yes, I agree. Malamut isn't undermining Robb. He's not saying that simultaneity is not related to causality, and it is merely orthogonality. He's those three words, simultaneity, orthogonality, causality, are being meshed, meeting up in a neat way, right? But I also completely agree with you that for 100 years you can't manage with only matter and radiation, classically conceived, right? In understanding chrono-geometry. So I just completely agree with you, and I wouldn't want to press the traditional relationism and try to overturn those 100 years. But Henrique, you would no doubt have something to say about Carlo's comments.
Sorry, I was just going to say that when you answered to that question in the beginning, I think you had a specific example in mind, and the choice of examples was broader than that. So for Hojman, Kuchar and Teitelboim, or for other projects, the problematic domain of discourse is, or the unproblematic domain of discourse, sorry, is not just matter and radiation. It could be something different. It could be, a problematic one is the spatial metric, for example. And the unproblematic one is how this metric will evolve, or how would you extract time from that. And I think that's also related to the original motivation of functionalism. In Harvey Brown's book, he talks about the chrono-geometric significance of things, and he tries to compare proper time with a Waywiser, and he says, look, it's easy to relate distances with a Waywiser. There's friction, and we know the mechanisms by which you're measuring this distance and so on. And he asks, what is the method of friction that is relating the length in space-time to time passed? And so there is a way of trying to articulate these two different domains so that the spatial metric is less problematic than its evolution, than its dynamics, or than the temporal metric. And I think other projects classify the problematic and the problematic discourse, not in terms of matter and radiation, but in terms of spatial concepts and space-time concepts. And I think that's where Barbour and Bertotti need to go to naturally when they leave the standard particle, Newtonian particle relationalism, and go to this field relationism. So yeah, that would be my comment on that.
Yes, I mean, I would only say thank you, Henrique, because I agree with what you said, and I should have picked up on that. I don't know how Carlo feels about that comment.
It's fine. I think it made concrete what I said at the beginning, that what we want to call unproblematic, it's what is being discussed. So that's a troublesome part, and that's a problematic part of the story for a physicist. I have a colleague in Marseille who was a relativist, Thomas Schuller, for those who know him, who always tried to convince me, and he sort of succeeds sometimes, that once you are a relativist, spatial distances are extremely hard things to measure. In fact, you will never measure them. The only thing we measure, the only real instrument we have is clocks. And in fact, today the meter is defined in terms of the second, not the way around. So, and in fact, there are attempts to define space-time geometry only in terms of proper time. So in his view, the unproblematic time is proper time.
Right.
And the functional enterprise that we should, actually the way we should teach GR, in fact, the way he teaches GR, is that we only measure time intervals, so there is only proper time, and the way they go together is general relativity. So I don't want to endorse his point of view. It seemed to be a little bit extreme, but it's a viable, defendable point of view. Maybe you want to rederive general relativity from a proper time, and maybe that's useful something. I don't know.
Yeah, no, I completely endorse that. I agree completely.
You want to derive everything just from the spatial metric. That's also, we might learn something about it, but certainly we're not in the situation in which there is an agreed unproblematic thing from which it's we all want to derive the four-dimensional metric.
Absolutely.
Right. Totally agree. And yes, nice to hear about Schuller's outlook. There's a lot of truth in the fact that ultimately we have clocks. It isn't just the numerical accuracy of the clocks that make the standards metrology community pick on that. There's also kind of to lay out the spatial distance with the successive placement of a rigid rod. Well, that's a process in time. And you make a record on a sheet of paper of how many times you laid the rod down. So it's the empirical protocols, even apart from these physics details of accuracy, themselves make instantaneous spatial geometry not totally okay to a naive empiricist or a strong-minded empiricist. Thank you, Carlo. Yeah.
Yeah. There was also I think in the case of HKT, I think it is more towards the difference between dynamics and kinematics. I would say I think what they see there as the okay part is just the kinematic space-time structure, And yeah, and so it's more towards the Lovelock theorem, which was related to Pierre's question.
So sorry to interrupt, just to say, because there's around 50 people, but either they're shy or not raising hands, that feel free to unmute and go in the discussion spontaneously. Yep.
Hi, it's Martin Green. Sorry, most of you don't know me. I'm informally affiliated with Perimeter Institute. My thesis work was actually very much related to the HKT paper. And I found that very, very interesting work. And it's interesting to see how it's still persisting. But I want to come back to this question of matter and the importance of matter and relate it now to the discussion of clocks, because the only way we have a clock, the ability to measure time, is that they're made of matter. So it's very difficult to think of excluding all matter from the analysis. Let's deal with a space-time that has clocks, but our clocks have to be made of matter. So I guess that's, I'd like some response to that.
Well, yeah, I myself would just ask Henrique to maybe comment. I endorse what you say. There are specific physics things that come to mind, but I would like to go second, or maybe infinitely at the back of the queue on commenting on this. Thank you, Martin.
Sorry, Martin, I had a little problem here. You were saying that everything that all instruments are made of matter. Is that right?
Yes.
Yeah.
So because our only access to space-time is through observations of matter.
Yeah, I agree with that. But I don't think that we can make a theory. There is this. Jeremy's probably more capacitated to answer this question than I am. In fact,
Can I try to answer that, because this is a general point. Maybe I'm opening a kind of worm here, but one thing is to say that we cannot do A without B. One thing is to say that we want to build a description of the world based on B. They're very different things. I mean, we cannot do science without our brain, but the world presumably exists without our brain. We cannot talk without, maybe it's just me, but I think that we should distinguish the foundationalist problem. Where do we start from the physical problem of giving a description of what is there that works? And then the questions can always be turned around, right? We can, because whatever object you want to put first, you can ask how it is recovered then within the theory you have. It's a standard example, right? We don't see the electromagnetic field with the object like this pen. Right, but we don't see object, we only see the photons that come from the object. So there are no objects, there's only radiation, right? We only see the electromagnetic field because light is an electromagnetic field, because touch is an electromagnetic force. So we have to build everything in terms of the electromagnetic field. No, come on. I mean, we can build things with quarks and electrons and matter or molecules. Or I think it's very dangerous to it's very dangerous because it's always failed in the past. This game of trying to find the final ground on which we build. It has, right? I mean, observational propositions have failed. Matter has failed. Spirit has failed. God, well, I'm not going to there. It's even my arguments. Everything is clocks. I don't think I would subscribe my colleagues' view that now we have to start against physics in terms of clocks. Certainly not. Clocks are a device. I only put it there as an argument against the opposite idea. We should only start from a three-dimensional metric. I think what we do in science, and sorry if I'm jumping in such a large theme, is to positive description of the world and see whether it matches with the world that we observe, and whether the notion we use are coherent with this description of the world that can be reconstructed therein.
We have a tendency to try to decompose the world into component parts, whether they be space-time or electromagnetic field or other forms of matter. And as we develop theories that pick one of those component parts, setting aside the others, I think we risk very much giving too much of a status to that part, and as a result, perhaps coming to conclusions that aren't really justified in that process. So one of the areas that I'm particularly interested in now is the notion of history. And none of our physics theories really addresses the significance of historical records and how we progressively accumulate our usable information over time. And everything we know is actually in our memories. And so in our minds, we have a model of the world, and that model is informed by all of the knowledge that we've accumulated over time and the fact that we're continually accumulating it now. And so one could look at it and say, well, all we know about space and time and matter is really nothing but a record of history. And that record of history is actually in the present. The past doesn't exist now, it's just the memories of the past. And so we need to, this goes back to those notions of causality and you know, Sorkin's causal sets and so on, except the causal sets don't talk about the matter. They only talk about the causal connectivity of events. So I think that we really have to be very careful about excluding matter from the outset or from any kind of analysis, and in fact, recognize that our memories are all based on matter. And so I think it's very important that we include matter in whatever analysis we do.
Nobody, I think in this discussion, nobody has suggested to exclude matter from the way we understand the world. It was the other way around. It's my comment was, I don't think we can derive space-time chrono-geometry only with matter without thinking that there's a gravitational field. But
yes,
the current description of the world, we have Dirac fields, we have electromagnetic fields, and we have gravitational field. That seems to be the good one from a physicist's point of view so far.
I had actually understood it in the other way that you, what your argument, Martin, I thought you were saying, can't we describe everything just with matter or with observational, empirically accessible objects and or directly empirically accessible objects? And I think there are problems in that route as well. These are, in philosophy, I think these are, people have in one way or another tried to articulate that. And you get down to something that's called Newman's objection. It's if you try to phrase all of your theory in terms of just one subset of terms, which are let's say the observational terms, then you find that this does not really impose many restrictions on the type of theory that you have. Just cardinality constraints on your theory can in fact you can in fact reconstruct all possible relations, for example, if you're given a set with enough cardinality. And so it's very difficult for you to extract everything you want from a theory just from a restricted subset of things that are directly, let's say, observationally accessible or empirically accessible. You have to include more things, the relations themselves, for example. And I think in that way, you would be putting into the back door, in a certain way, space-time, which encodes these relations between these objects.
I'm not suggesting that we exclude space-time, but I think that we have to develop a model which is, if you want, a holistic model. So we need to recognize both the space-time, which we infer from our observations of matter. When we talk about matter, it can't exist as we know it, without the notion of space and time. So they're codependent, but to think that one can formulate a theory that looks, I'll just do a theory of space-time and not include the matter in that theory, or separately to do a theory of matter that doesn't consider space-time geometry, I think both of those are too exclusionary, and that may be the cause of the source of many of the problems and the paradoxes that we obtain in theoretical physics. Anyways, thank you very much.
Yeah. Well, I certainly concur with that. I think we broadly agree in these last several comments that one needs both. As Carla was saying, you can't manage with just matter as classically understood. You have to accept the gravitational field, also called space-time.
Yes.
So Marios, you may have, do you have a queue of folk? I see Lucian on my screen.
Yeah. Hi, can you hear me?
Yeah, I can hear you.
Okay. Yeah. So one question that I was wondering about is the role of ontology and operationalism, which sound like they might be examples of.
Lucian, can you talk louder?
Okay. I'm going to see if it's better.
Yeah.
Okay. So one question is the role of operationalism and ontology. So so the operational properties are maybe a subset of the ontological ones, and it seems like that may be an example of your sort of O and T.
Lucian, can you please talk a bit louder? We cannot hear you very well.
It's not a problem. I'm talking pretty loud, so
Now it's good. Yes.
Okay, now it's good. So I'm sitting very close to the computers. So in some theories like general relativity, there's a very clear idea what the ontological quantities are. So in general relativity, it's generally agreed that the ontological quantities are those things that are invariant under different monisms. Whereas it's not so much agreed what the operational quantities are. And to some extent, that's because they're contingent on who it is who's doing the observing. And I think a lot of the discussion we've just had connects to that problem. Whose clock is it? Who's looking at the world? You could attempt to nominate some set of ontological quantities to be your operational quantities. So one example would be. No, I don't have my hands on the microphone. Okay. Well, maybe I'll leave it there. It's the question of nominate. Can you hear me now?
Yes.
Yeah.
Yes, we can hear you.
Yeah, I think it's very sensitive within about 1 or 2 centimeters of where exactly you are in relation to the microphone, Lucian.
Okay. Yeah, I've had problems before, periodically on this computer.
So when you move your head to, an inch, sometimes we lose you slightly. But careful.
I don't think
one can hear you. Yeah.
I think it's not. I think it's some problem of feedback, because when he starts the sentences, it's loud, but then it muffles as time goes by within a sentence. But anyways, yeah.
Okay.
But you could nominate some part of your ontology to be the speculated method for operational access.
So here's
and we're going to give an example. Yeah.
So here's an example. In the context of general relativity, you could nominate scalar fields taking values in coincidence as your operational quantities. And if you do that, that would give you the possibility of building clocks, for example. That would be sufficient in some systems to build clocks. And it would give you other things. And so a subset of scalar fields in coincidence would be one way of nominating your operational quantities. But if you did that as an example, then you could just look at scalar fields constructed from the gravitational metric. And so you'd have the possibility of an operational world living solely in the gravitational degrees of freedom. Did you hear what I said?
I did, yeah. I in some sense of operational, I agree that scalar fields built from the metric might be operational. And I agreed with your opening comment that GR could be clear about ontology, but vague or open-ended about what is the empirical access. And in a way, that's in the nature of a theory that claims to be fundamental, that of course it won't tell you how, it won't tell you in detail how measuring instruments are meant to confirm its description. And it may be a specific thing about a space-time theory, that of course it's not a theory of instruments. One might say that quantum theory, being a theory of matter, is by definition in principle committed to describing its measuring instruments. It's just a long story that never gets said in the textbook. But GR, being a theory of space-time, is not by definition, if the textbook was sufficiently long, going to spell out how an instrument works, because it's not a theory of matter. Anyway, sorry, that's just an immediate generic sort of response.
Can I ask to both of you, to either of you, how would you articulate this difference between the GR and electromagnetism? Where is the differentiating point?
So I think you could do exactly the same thing I just mentioned in the context of electromagnetism. Perhaps it's not regarded as being as necessary because GR is conceptually more slippery.
Can you repeat the last thing you said?
I mean, perhaps in the context of GR, it seems like it's more necessary to get a handle on what the operational quantities are, because it's more slippery. But I think you can do exactly the same thing.
Okay.
So,
whereas in quantum theory, it's almost the other way around. You have more access to the operational quantities. It's not clear what the ontological quantities are.
Yeah. Oh yeah.
Yeah. Right.
Doubt.
I agree. And I also agree that it's like for the way I understood Lucian, the point would be valid for electromagnetism equally with GR.
Yeah.
Historically, there's been a discussion about the ontology of the electromagnetic field, which is parallel this the same discussion of the gravitational field. I mean, even today, I think there is some remaining discussion whether we should think electromagnetism as just some complicated feature of matter seen from a distance, or whether it's more convenient to view it as the description of some entity, which is the electromagnetic field itself, which I think is a much more useful perspective in physical terms. But I mean, I'm completely with you. The discussion is parallel.
Yeah. Agreed.
So I have a comment if there's nobody else right now. So I think in what is being said, I think is that so what is troublesome and what is well-defined is not necessarily splitting matter and gravity, as Lucian is pointing out. You may find beebles or good observables, or make a sort of operational interpretation only in pure gravity. And I think that's what also Carlo is saying about the gravitational degrees of freedom being real degrees of freedom, which we of course know is true. But But I guess this methodology and strategy that Jeremy has explained to us, you have to use it depending on the context. So a question I have, like, I don't know if you've thought about this, but so let's say that now we have space-time, a classical space-time, and on top of it, we don't have classical matter, we have quantum matter. Not some fancy deep quantum gravitational regime, or not even quantum field theory, just quantum mechanics. So let's say a superposition of matter. In this case, it's not clear whether the okay part is matter, because now you have all the craziness of quantum mechanics. So it wouldn't be evident to me in that case that you would try to use your matter theory to define your space-time physics. You might need to go the other way around.
I totally agree with that, of course. Yeah. Well, I just make the obvious historical comment that the 17th century so-called mechanical philosophers, they had supreme cognitive optimism about the future of science, believing that their notions of corpuscle or mass or body would be an unproblematic and successful foundation for everything. And of course, matter got ever more mysterious. And with the quantum revolution, it got so mysterious that we're still, confronting the measurement problem and interpretative difficulties that we don't have a consensus about. So,
Jeremy, Henrique, can I try something slightly different on this program? Could I interpret it? This is a follow-up from the previous discussion. Jeremy and Henrique, could I view this way? Suppose I want to start with the O part.
Yeah.
Which includes the gravitational field. And includes, of course, matter, and includes the electromagnetic field, which after all is what we study at school. But I take the gravitational field very much as a brother of the electromagnetic field. I still have a T, perhaps, which is, wait a moment, we do think in terms of temporal relations, spatial relations. We have a relational notion of space, which is precedent to all that, in fact, precedent to Newton itself. We have a notion of succession of time. So now we can articulate a functionalist understanding, perhaps, I don't know, I'm just, of what we actually meaning by we're next to one another, what to actually meaning that we're at a distance of 3 meters. I mean, this pen is next to me, but Jeremy is very far away from me. And more heavily, what it means, this is before, this is late.
Yes.
There are a lot of open questions. I mean, definitely, if I just look at the mathematics of GR, I immediately don't see the flowing of time. So there's a lot of baggage to be added here.
Yes.
Can't we use this functionalist approach as a reductionist strategy for saying, all right, so if I believe that the world is what is described by the physics book, just in physics terms, in terms of fields, I have to understand the passage of time, the distance, and the geometrical intuitive notion of spatiality, only not as primitive as Kant had want or anything like that, but as functional, building on these fields.
Yes.
And perhaps this may help us, because if then we go to quantum theory, we could bring with us this functional understanding of what is time, what is space, without having to have them into the fundamental ontology as, I don't know, some philosophers would like to have even today.
Yeah, well, so I very much agree with what you say, that this is, including the last part, that they need not be fundamental. But what it reminds me of in the first part of what you were saying was the much beloved, late lamented Abner Shimoni, right? Who many of us will have fond memories of, both as a person and as an intellect. And he had this phrase, I think it was his, of closing the circle. So the idea was that in any scientific enterprise, at the end of the day, one needs to explain from the postulates how we have knowledge of the evidence that confirms the theory. And so there is a kind of responsibility for any, what you might call world building, to not only be confirmed, but to have a, well, I mean, it's rather like we were discussing with Martin and Lucian. I mean, the theory of the instrument. There needs to be a consistency and a recovery in the theory's own terms of its own evidence, a construal or a sensible description of its own evidence ultimately. And for our everyday understanding of space and time, this is a big enterprise because, as you say, we have memories, we have the experience of succession and the flow and so on, which philosophers have a large heated debate about in both logic and metaphysics. So that enterprise is definitely a responsibility for the scientific and philosophical endeavor overall. Yeah.
And to add to that, I think, Carlo, what you described is in a certain way the goal of some people, maybe Huggett or other people that want to apply functionalism to things like quantum gravity. They want to find something unproblematic, some unproblematic realm on which you can define space-time, and then you can transfer this realm to the quantum one and find the equivalent role of space-time there. It might not have any, but I think that's one of the applications.
I mean, I should just say, advertising the philosophy community a little bit to the consortium as a whole, what Carlo said reminded me of David Chalmers, who has a paper specifically about the changing concept of time between the everyday understanding and the scientific, which he discusses in terms of this functional role jargon. But also there is a book from about 3 years ago by a philosopher, Callender, but it's not spelt A-R, it's L-L-E-N-D-E-R, Craig Callender in Philosophy at San Diego. He has a specific book called What Makes Time Special. So these issues of the scientific understanding of if you like, explaining away the apparent flow of time is treated in that book. But Henrique and I, we have misgivings about some technical passages in the book, but overall, it's a good recent book on the topic.
Okay, so we're at about 2 hours. I promised Jeremy will make it 1.5 hours, but as the discussion was interesting, I didn't want to cut it short. I hope you had time on your side.
Yes, I'm fine myself, Marios. I'm very grateful to everybody's participation, but I'm afraid my answers are a bit long because I love to chat. So I took it I can stay longer, but people must go when they need to go or wish to go. Yeah.
So there is still a great number of people. There's around 40 people. I don't know if somebody wants to unmute and comment or ask a question.
Well, I do have a question. Thank you so much for this presentation, because it allowed me to appreciate something that it was not on my radar before, namely the relation between functionalism and relationalism. And you were mentioning in particular with respect to the case of the gravitational field, Knox functionalism and the relationalism in Haggett and Bellot. I didn't appreciate before this connection, but I was wondering whether in functionalism, people always stress the relational aspect. You were putting this very well, saying that in functionalism, concepts and properties are always defined by the relation with the other concepts or other items. But I wonder if this is a definition that is accepted by everybody who work in functionalism. And otherwise, if yes, then can we say something more? Can you tell us something more about how you see this relation with relationalism?
Right. Yes. I think. Thank you, Francesca. A kind question and a very good one, because of this ambiguity with the word relation. I think when we're doing philosophy and physics of space-time, it always has the connotation of relations between material objects and the Leibniz-Mark tradition. But in the philosophy, the functional role or the idea of the web or pattern, it mentions the word relation, but they are typically, it's the relationship of causation between one property and another, or some other law-like variation, co-variation. So when functionalism got labeled as that in the 60s by Putnam, Armstrong and Lewis, they really were mostly or almost exclusively thinking about mental versus material, and where the material might be the bodily behavioral of stimulus and response, or it might be the inner physiological. And in both, whether it was the inner physiological or the behavioral that was being related to the mental, these relations that were mentioned in the web or pattern, which was characteristic of a mental state, those were relations were things like caused by tissue damage and typically causing avoidance behavior, right? And, belief that it's raining is typically going to cause, as it might be, depression, because we all like sunshine, right? So that'll be a causal relation to another mental property. So there isn't, in that sense, any deep connection. But it's true that this okay troublesome jargon does naturally relate to the relationist tradition, of course. Though, as we were stressing, body is now much more problematic than Leibniz would have imagined. Well, of course, Leibniz, of course, was a genius, and he had his own heroic struggles with the microstructure of matter and of the continuum of space. But it's certainly troublesome, the nature of matter, in ways that Leibniz never dreamt of, even though he did have the credit of worrying about the microstructure of matter. Yeah, so I hope that answers a little bit. Yeah.
Well, it opens up questions, but it clarifies a lot where to look at. Yeah.
Right. Thank you.
So I see there are many students also and postdocs. I don't know, don't be shy if you want to ask a question. Just unmute and ask something. We can continue for another 5 minutes, maybe. Okay, well, if not, let's thank the speaker. Thank you very much, Jeremy and Henrique.
completely artificial. Thank you, everybody. Thank you, everybody. I congratulate the consortium. Never mind the speaker. The whole session is great. Thank you, Marios, and
thank you very much.
And, yeah. Okay.
Thank you very much as well, and stay healthy. See you next time.
Take care.
Take care. Yes.
Bye.
Bye.
Bye. Bye.
Bye. Bye.